All right, let's continue with number 2. This problem says what dimensions of this particular area where the barn is taking up one side of fencing, and then you have parallel pieces, so it's splitting it into 2 regions, would yield give dimensions of 22,500 feet if the farmer has 600 feet. Okay, she's got 600 feet of fencing, so how much would that yield? What we need to do here is come up with an expression for area. This is a rectangular area, so all of this area in here would be base times height or length times width. So we need to name this dimension, and I'm going to name that L. Okay, so the area of that region will be length times width, or L times X. Okay, this is, and what we're shooting for is to make it equal that. Okay, now we got to know how much fencing we have, and we're going to use 600 feet of fencing is available. So let's see if we're going to use all our fencing, what that would be. So we could come up with this is a piece of fencing, this is a piece of fencing, and this is a piece of fencing, and all 3 of those pieces of fencing are X units in length. So 3 times X plus 1 piece of fencing, which is L, together will make the 600. So I'm going to do what I did in the first example, is rewrite one variable all in terms of another, and I'm going to choose to solve for L, which will put it in terms of X. So I'll subtract 3X from both sides, and I'll get L is 600 minus 3X. Now I'm going to substitute this expression in here for L, and then my area will be just in terms of one variable. So if I want to call it A as a function of X, now I can, because it's all going to be in terms of X, is equal to 600 minus 3X times X, or A of X is 600x minus 3x squared. So this is my area function. All right, the first part of this question says find the dimensions of area that will yield this square footage. So we can do that. Let's see. Set this area 600x minus 3x squared equal to 22,500. So we'll do that. All right, now what we're going to do is solve for we're going to solve this quadratic equation. You see how it's x squared and it's a quadratic equation. So let's get a 0 on one side. And I'm going to subtract 22,500. And I'll get a 0 on that side. Okay, now I want to solve this quadratic equation. You are allowed to do this when you have an equation. You can divide both sides by the same thing. I'm going to divide both sides by -3, which will simplify my equation just a little bit. I have smaller numbers. So if I divide this side and this side by -3, I'm going to get x squared minus 200x plus 7,500, I believe. Let me make sure I'm writing this down right. Yeah, 7,500 is equal to 0. All right, I think this is factorable if you want to try to factor that. You can also just use quadratic equation. I think that's what I'm going to use this time. X is equal to negative b, negative 200, plus or minus the square root of b squared, negative 200 squared, minus 4 times a, which is 1, times c, which is 7,500, all over 2 times a. All right, x is a positive 200 plus or minus the square root of, I think this is 4,000, no, or 40,000 minus 30,000 all over 2. So x is 200 plus or minus the square root of 10,000 over 2. This is 200, the square root of 10,000 is 100. So this is going to be x is 200 plus or minus 100 over 2. 200 plus 100 is 300 over 2. 200 minus 100 is 100 over 2. This is 50 feet. This is 150 feet. Okay, these are my 2 dimensions right here. All right, so what I'm going to do here is, what they asked me to do is say, what are the dimensions? These are not the 2 dimensions for x and L. These are 2 options for x. And so what we find here is that there's two answers to this. So here's option 1, and here's option 2. All right. If we need the area to be this much, you could make x be 150. X could be 150 feet, or x could be 50 feet. If you let x be 150 feet, how you would find L is, you could solve for it. You could stick 150 in here for x and say 600 minus 3 times 150 gives me, what would that give me? Let me make sure I'm writing this down right. Oh, another 150. So that would be, x is going to be 150 is what you get. I mean, L would be 150. This would make a square region. Okay, if you only let x be 50, what would L be? L is going to be 450 feet. So we have two options available to give us the same square footage if that's what we were after. Now, if that's not what we were after, part B says, what dimensions would you need if you wanted to maximize your area? So that's not necessarily the maximum. So let's see, what would they be? We would do the same thing is we would use the fact that we have this much fencing available. We would come up for an expression with area, which is this basically. Here is our area. Here's our area right here. We don't set it equal to that because that's not what we're interested in this time. We want to maximize it this time. So what we do here is deal with this expression of area. And we realize that this is a quadratic function. And so in this case, we want to maximize it. So let's think about this is, if you want to rewrite it with the leading term, minus 3x squared plus 600x. This is a quadratic function facing down with a maximum occurring at the vertex. And so this is what we know. H is negative b over 2a. Negative 600 over 2 times negative 3. Negative 600 divided by negative 6 is 100. So the maximum area for this fencing will occur when x is 100 feet. Well, what will that maximum area be? A of x, what will it be? Well, we'll plug in 100 into this expression and find out what that'll be. And when we plug it into there, we get this. We get that it is, where did I put it? The maximum area is going to be 22,500. No, that's not right. That's the other one. Is that what it's going to be? Hang on just a second. Let me make sure I like this. I don't think that's right. My maximum area is going to be, let me plug it in and see. When I put in 100 there, negative 3 times 100 squared plus 600 times 100 gives me 30,000. So 30,000 is the max. Is the maximum square foot that we could get. So, let me just see if I like that. Yeah, that looks good. I'm going to graph this on my graph calendar as a check. So let me see. I'm going to enter this expression. I'm going to enter negative 3x squared plus 600x. And so on my window, just as a check, the x value is going to be, this is the length. So I'm going to go maybe, this is as big as one of my dimensions is. Maybe I'm going to go, I'll go out like, I think 200 would do it for how far to the x I need to go. And then how much area, I'm going to go maybe to about, I don't know, maybe 40,000 just to see, because I know that we can get that much just to see what the maximum will be. So I'll say x is negative 5. I like a little buffer. I know it won't go negative, but I always like to start negative. To, what did I say? Okay, I said negative 5 to 200. I'm going to skip by, my scale is going to be 10. And then y is, of course, positive, but I like a little buffer. I say negative 5 just to go a little bit negative. And then the maximum I'm going to say is 40,000. And I'm going to go by scale. scale of 10. And then I'm going to hit graph. Oh, it gave me a pretty nice graph. All right, there's my pretty nice graph. Can you see it? Okay, so now I'm going to hit second and then trace. And I'm going to hit number 4, which is maximum, because just as a check, see if I like my numbers. I'm going to go to the left. It says that left bound, go to left side of the max. I'm going to go to the right and my right side of the max and hit enter. And then it says guess, and I say yes. And it lands in the middle at the maximum point, and it says X is 100 and Y is 30,000. So that makes me feel good about my answer. Okay, so that's a way you can check if you are wanting to check graphically as well. Okay, so now let's go on to the next one, which is about hitting a golf ball. So let's go ahead and do the hitting a golf ball one. So we have a couple of examples where we're talking about projectiles. So sometimes they talk about rockets being projected into the air. Sometimes they're talking about golf balls. Sometimes they're talking about throwing rocks. But what these all have in common are the gravity force that's working on all of them. So let's do these next couple, which have to do with that. So right here, it says a golf ball is hit so that its height h in feet after t seconds is given by this equation. So this is the height, h of t, which I'm going to change this to s of t. I might have already changed it by the time you get your worksheet, which is equal to negative 16 t squared plus 60 t. And what this is the negative 16 is the gravity force. It's negative because it's acting down. If we choose positive to be our up to be positive and down to be negative, this is its initial velocity. So that's how hard it was struck. It says, what's the initial height of the golf ball? That's part A. So if this is the height, S of t represents the height, then it's the initial height is when time is 0. So to answer part A, the initial height occurs when t is 0. So S of 0 would be, we plug in negative 16 times 0 squared plus 60 times 0. So S of 0 is going to give us 0 plus 0 or 0. How high is it initially? It starts on the ground, basically, is what it's telling us. So its initial height is 0 feet. B says, how high is the golf ball after 1.5 seconds? Okay, so part B, how high is it after 1.5 seconds? We just say, well, plug in 1.5 into this, and we can figure that out pretty easily. Oops, that's not 1.6, that's 16 t squared plus 60 times 1.5 squared. All right, and when we plug all that in and evaluate it, we find that it is 54 feet in the air after 1.5 seconds. Okay, then the last part says find the maximum height of the golf ball. How high does it go? All right, so if we look at this equation, it is again a parabola facing down. This is going to be the maximum height, and so the max height occurs at the vertex, HK. So in this case, H is a time, and K is a position, or S of t. This is where the maximum height will occur. So again, this coordinate H is negative b over 2a. So it's negative 60 over 2 times negative 16. So H is going to be negative 1.875 seconds is what we get when we plug that in. How will we find the maximum height? You just evaluate S at 1.875 seconds. We plug that into this equation, and it gives us that the maximum height will be 56.25 feet. Let's write a sentence. The golf ball reaches a maximum height of 56.25 feet after 1.875 seconds. All right, there we go. There's that one. Here's the last one, and it has to do with, do I want to do this one? No, I don't want to do this one. I want to do a different one. I want to do the one that has to do with revenue because I want to introduce this common equation. This is profit. The profit is equal to revenue minus cost. Revenue. So what is profit? It is the amount of money that you get to keep after your costs are paid, after your employees are paid and your bills are paid and all that. That is what you get to, that's your extra money that you make, okay? Cost is how much it takes to run a business. Revenue is the amount of money you have coming in. So you sell something, you get all this money coming in, but you don't get to keep all that money. You have to pay your bills and your employees and whatnot. So after that's happened, that's what profit is. I just wanted to introduce this equation. This particular problem doesn't deal with profit, but if it did, and they gave you a revenue and a cost equation, you would need to subtract these two, subtract cost from the revenue to get the profit. This particular problem, though, has to do with revenue. So we don't have to worry about this subtraction because they gave us revenue, but I want you to keep that equation in mind because some of you guys are going to go into, business and you're going to need to know that. So this one says, suppose that the revenue in thousands of dollars that a company receives from producing X thousand MP3 players is R of X is equal to X times 40 minus 2X. So they give us a revenue equation, which is X times 40 minus 2X. So the revenue is, X represents basically the amount that they sell, and this is the price that they sell it for. So this is the total amount of money that they have coming in. But this is our revenue equation, and so they want us to evaluate what R of 2 is and interpret it. So R of 2 would easily be evaluated by plugging in 2. And so we get 2 times 40 minus 4, or 2 times 36, which is 72. So what R of 2 is 72. So what? What does that mean? If we had to interpret it, we would write a sentence which would say, when 2, what does X represent? It represents thousands of MP3 players. That's so dated already, MP3 players. But when 2,000 MP3 players are sold, 72,000 in revenue is made. That's how we would interpret that sentence right there. How many MP3 players should the company produce to maximize its revenue? And what is the max revenue? Okay, so again, now we're maximizing. So this is, let's see what this is. If we distribute the X, we get 40X minus 2X squared. So again, we get this parabola facing down. Is there ever a situation, I know you're wondering, when the parabola won't face down and we have a maximum but it faces up and we have a minimum? Yes. Many times you want to minimize the cost. So if you have a cost equation, the leading coefficient will be positive and it'll be a parabola facing up, and you'll want to find the minimum to minimize your cost. But here's another one where it's facing down and we're looking at maximum. So right here is our R of X. This is what it is in this case. Here's our vertex. All right. H in this case is X, which is the number of MP3 players they need to sell, and K is the maximum revenue we can make. All right, so H is negative B over 2A. This is going to be negative 40 over 2 times negative 2, which is going to be negative 40 over negative 4, which is 10. All right, 10 MP3 players is not the right amount. 10,000 is the right amount. So Let's write a sentence. In order to achieve a maximum revenue of, we're about to figure that out, they must produce and sell 10,000 MP3 players. That is funny how dated that is already. Okay, what's the max revenue got to be? Let's plug in 10,000 or 10. What do we say? H was 10 into our R of X. So what is R of 10? That's 10 times 40 minus 2 times 10. All right. 10 times 40 minus 20 is 10 times 20 is 200. The maximum revenue is $200,000. That's their max revenue. So here are a few quadratic applications.